Every mega bridge begins with one impossible challenge: crossing a gap that seems too vast to conquer. Here, engineers must connect two worlds separated by water, distance, and enormous engineering obstacles. Before construction begins, engineers must first understand the battlefield beneath and around the future bridge. Advanced drones map the terrain from above, creating a precise digital picture of the entire construction zone. On the water, survey crews use sonar to reveal the hidden terrain beneath the surface. The underwater survey reveals exactly where foundations can safely reach solid ground.
Deep drilling samples reveal what lies beneath the surface and determine how the bridge must be supported.
Every layer of soil and rock provides information that can change the entire foundation design. With the ground understood, engineers begin transforming measurements into a bridge designed to survive extreme forces. Computer models allow the team to test the bridge before the first piece of steel is installed. Engineers simulate traffic, wind, temperature, and other forces that the finished structure must withstand. The bridge is designed not to resist every movement, but to control that movement safely. Once the design is approved, thousands of people and machines must work together with extraordinary precision. The first machines arrive, and the empty construction zone begins transforming into a giant engineering operation. Before the permanent bridge can rise, workers must create a safe platform from which the foundations can be built. Huge steel piles are positioned with precision to transfer the bridge loads deep into the ground. Powerful hydraulic machinery drives each pile deeper, searching for the strongest layers beneath the surface. Every pile is monitored because even a small foundation error can become enormous high above the water. Together, these foundations create the hidden skeleton that will eventually support the entire bridge. Steel reinforcement forms the internal skeleton that gives massive concrete foundations their strength. The enormous steel cage is lowered into position, ready to become part of the permanent foundation.
Now the concrete pour begins, and thousands of cubic meters must arrive without interruption.
Fresh concrete surrounds the reinforcement, creating a massive structural foundation beneath the future bridge. Sensors monitor temperature inside the concrete because massive pores can generate dangerous internal heat. The first giant foundation is complete, giving the bridge its first permanent connection to the earth. Temporary construction systems are removed, exposing the permanent concrete that will carry enormous loads for decades. Foundation by foundation, the bridge begins establishing its path across the water. With the foundations secured, the bridge piers begin rising toward the sky. Steel reinforcement is carefully arranged so the concrete pier can carry enormous vertical and horizontal forces. Climbing formwork allows the pier to rise continuously while keeping every section precisely aligned. Day after day, the concrete towers upward, transforming the construction site into a giant emerging structure. Every new section is inspected before the next stage begins, because precision becomes more important as the bridge grows. At this height, weather can stop construction instantly, and safety always comes before speed. When severe weather arrives, crews wait, protect the equipment, and return only when conditions are safe. When the storm passes, work resumes, and the bridge continues its slow climb. Eventually, the towers become the dominant landmarks, rising hundreds of meters above the surrounding landscape. At these heights, every movement demands concentration, training, and absolute respect for safety. Heavy steel components are lifted hundreds of meters into the air,
and positioned with extraordinary accuracy.
Surveyors constantly check alignment because tiny errors become serious when multiplied across the full height of the bridge.
Now the towers stand ready, but the enormous space between them still remains. The next challenge is preparing cables strong enough to carry the enormous loads of the future roadway.
Each cable contains thousands of carefully manufactured strands designed to work together under tremendous tension.
The completed cables are transported to the bridge and prepared for installation. The first major cable is lifted toward the tower, beginning the system that will support the roadway.
Engineers carefully control cable tension so every part of the structure shares the load correctly. As more cables are installed, the bridge begins developing the strength needed to support its deck. At every anchorage, enormous forces are transferred into the structure through precisely engineered connections. The main cable now stretches across the towers, creating the backbone from which the roadway can eventually hang.
Vertical connections transfer the roadway loads upward into the main cable and towers. From above, the cable network reveals the hidden structural logic holding the future roadway in place.
Now the roadway begins arriving in enormous sections, transported across the water.
Each deck segment is engineered to connect perfectly with the sections already installed. A giant crane prepares to lift one of the heaviest pieces of the bridge. Hundreds of tons of steel rise slowly from the water, suspended entirely by the crane. The segment is moved into position with centimeter-level precision.
Once aligned, the segment is locked into the growing bridge with massive structural connections.
Segment by segment, the roadway advances from both sides toward the center. Balanced construction keeps the enormous structure stable as the roadway grows outward from the towers.
Underneath the roadway, inspectors verify every connection before construction moves forward. The bridge is beginning to resemble a road, but every unfinished section still represents a major engineering challenge.
Critical steel connections are welded and inspected to create a continuous structural system.
Specialized inspections search for hidden defects that ordinary visual checks could never reveal.
After years of work, only one enormous gap remains between the advancing sides. Final connection requires calculations for temperature, wind, movement, and structural alignment. Everything is ready, but the final piece must fit under real-world conditions, not just computer predictions.
Steel expands and contracts with temperature, so the exact moment of connection matters.
The final segment approaches by water, carrying the moment the entire project has been waiting for. Slowly, the final piece rises toward the gap that once seemed impossible to cross. Centimeter by centimeter, the final segment moves toward its exact position. The impossible gap is now only a few meters wide. Hydraulic systems make the final adjustments until the structural connections line up perfectly. The first bolts enter the connection, permanently joining the two sides. Each bolt is tightened to a precisely calculated force, securing the final connection. For the first time, the two shores are connected by one continuous structure.
But completing the structure does not mean the bridge is ready for traffic.
Expansion joints allow the bridge to move naturally as temperatures change.
Drainage systems are installed to keep water away from critical structural components. Safety barriers are added to protect drivers while preserving the structural edge of the roadway. Modern lighting systems are installed to make the enormous roadway safer after dark.
Sensors are installed to continuously monitor movement, vibration, temperature, and structural performance.
Cable protection systems help defend critical components against weather and corrosion. Inspection vehicles now examine the completed roadway from end to end.
Inspectors check critical welds and connections for defects before the bridge can carry public traffic.
Even the hidden foundations are inspected, because the strongest bridge depends on what cannot be seen.
Divers inspect submerged structures where water can hide damage from ordinary inspections.
Inside the monitoring center, engineers can track the bridge's behavior in real time.
Controlled heavy vehicles test how the finished bridge responds under carefully measured loads. Sensors measure the bridge response and confirm that the real structure behaves as engineers predicted.
The bridge passes its controlled tests, bringing the opening day closer.
After years of construction, the final temporary equipment is finally removed. At last, the construction site has become a finished bridge, ready to serve the public. The workers step away from the structure they spent years building, leaving behind a permanent connection between two shores. What once looked like an impossible gap is now a functioning route connecting communities and economies.
The first public vehicles approach the bridge, beginning a new chapter for the region.
A journey that once required enormous detours can now be completed across this extraordinary structure. Every vehicle crossing the bridge represents years of engineering, construction, testing, and human effort.
From below, the enormous structure reveals the hidden framework carrying every journey above.
Below the roadway, ships continue moving through the waterway, protected by the bridge's carefully calculated clearance.
As evening arrives, the bridge becomes more than infrastructure. It becomes a landmark.
After dark, thousands of lights transform the bridge into a glowing pathway across the water.
Cables that once existed only as engineering calculations now carry real traffic through the night.
Every morning, the bridge begins another day of carrying people, goods, and opportunities across the gap.
Even after completion, the work never truly ends, because a mega bridge must be maintained throughout its life.
Regular inspections protect the cables and structural components from corrosion and long-term wear. Continuous monitoring helps engineers detect changes early and keep the structure performing safely.
The bridge will face storms, strong winds, heat, and countless other forces throughout its lifetime. Its strength is tested by nature, but the structure is designed to move safely under changing conditions.
When the storm passes, the bridge remains, continuing the purpose for which it was built. Every foundation, tower, cable, beam, bolt, and roadway section works together as one enormous system. Something as small as a single connection becomes part of a structure capable of carrying thousands of people every day. The bridge does more than cross water. It connects communities, businesses, services, and opportunities. Faster connections can also help emergency services reach people when every minute matters. Freight can now move more efficiently, opening new possibilities for regional trade and economic growth. For ordinary travelers, the bridge becomes part of everyday life, even though its construction was anything but ordinary. From a distance, the finished bridge looks effortless, but every meter represents years of work. Behind every visible beam are thousands of calculations, inspections, decisions, and East Asian human hands. The finished bridge carries a hidden history written into every component by the people who built it. For the engineers, the final structure represents something greater than concrete and steel. A problem solved through persistence. When people looked at the gap, engineers saw a challenge that could be measured, designed, and conquered. The water that once separated the two shores now flows quietly beneath a structure built to endure. What once required a difficult journey has become a direct path from one side to the other. The bridge now stands as proof that extraordinary challenges can be overcome one carefully planned step at a time. From the first survey to the final connection, every stage transformed an impossible idea into reality. The road ahead now symbolizes the distance humanity can cross when determination meets engineering. A bridge this enormous is never built by one machine or one person, but by thousands working toward one vision.
Its greatest achievement is not its size, but the countless journeys it will make possible.
Where others saw an impossible gap, human ingenuity built a path across it. This is how the mega bridge defied impossible odds.